Dear students, welcome to the course on Statistical Methods for Psychological Research Part 2. In this lesson, we are going to learn about the critical values, significance level and p-values. What are we going to learn in this lesson? Let us look the learning objectives. After completing this module, students will be able to understand the statistical decision making through critical value and types of tests, and understanding the formulae methodology of critical value, p-value with g-test along with examples. Also discussed on the factors that decide the critical value with respect to different issues like degrees of freedom, level of significance, type of sampling distribution, types of tests, etc. Further, you have to understand the critical value, p-value and problem solving for computing values. Coming to starting the lesson part 1, it is part on overview of statistical decision making. Scientific decision making is one of the most essential decision making when the decision making is a part of science. Scientific decision making involves the use of data mining and big data to source relevant data to inform decisions. Applications of software, logic and predictive models to analyze the decision making scenario, which is more scientific now. Forecasts to consider the possible implications of business decisions is the objective under this category. Coming to the statistical decision making, this decision making deals with number related information. Statistical decision making theory is concerned with making of decisions when in the presence of statistical knowledge, which means data. It sheds light on some of the uncertainties involved in the decision problem. It is based on the statistical inference by involving the concepts of point and interval estimation theory, parametric and non-parametric hypothesis testing. Possible approaches in statistical decision making, if you observe, there are two correct decisions in which rejecting the null hypothesis when it is false is one correct decision and accepting the null hypothesis when it is true is another correct decision. Coming to the wrong decisions, we have rejecting the null hypothesis when it is true or accepting the null hypothesis when it is false. So, these four possibilities are there in statistical decision making. Nature of two-sided tests, if you observe, see two-sided hypothesis tests have two rejection regions and consecutively two critical values. As the critical region is split into two parts, the levels of significance shall be alpha by 2, making the total for both areas equal to the significance level. Examples on two-side tests, if you observe, see the probability plot, it's showing that the critical value on the rejection region for a two-sided g-test with significance level is 0.05. So, 0.05 to be divided into two parts. So, critical region of Z will be at 1.96 both sides. What it means that G equal to 1.96 plus to the right hand side minus 1.96 is on left hand side. So, this Z less than or equal to minus 1.96 or Z greater than or equal to 1.96, these can be considered as critical regions. One-side tests. One-tailed tests have one rejection region and hence only one critical region. You can observe the region either to the right hand side or to the left hand side. The total probability goes into that one side. The probability plots display the values in the right side or left side of g-tests. These tests can detect effects in only one direction. Critical values to determine the statistical significance is a very interesting part in which we have to understand the sample space as well as the critical region. So, critical region will be helpful in understanding the critical value. Critical value is the boundary between non-significant and significant results in a hypothesis test. Test statistics that exceeds a critical value have a low probability of occurring if the null hypothesis is true. Critical value to determine the statistical significance. So, we have to understand when test statistic exceeds these cutoffs, you can reject the null hypothesis and conclude that the effect exists in the population. In other words, they define the rejection regions for null hypothesis. Constructing the confidence intervals using critical values is another important task in testing of hypothesis. Confidence intervals use the same critical values as the corresponding hypothesis tests. Confidence levels is defined with 1 minus alpha, hence the critical value for alpha equal to 0.05 provides the confidence interval, that is 1 minus 0.05 equivalent to 0.95, or also call it as 95% confidence. Formula for confidence interval, if you observe, lower limit equal to sample mean minus critical value into standard error of the mean. This is the lower limit of confidence interval for population mean. Similarly, upper limit of the confidence interval for population mean is upper limit will be sample mean plus critical value into standard error of the mean. So, what is critical value? As the name itself indicates the meaning that it is a very important value. A critical value defines a region in the sampling distribution of a test statistic. These values play a role in both hypothesis tests as well making confidence intervals. In hypothesis tests, critical values determine whether the results are statistically significant. For confidence intervals, they help to calculate the upper and lower limit of the confidence intervals. Dear students, let us summarize the part 1 of this lesson, in which we discussed about the scientific decision making, statistical decision making and nature of the tests, computing the critical values, importance of confidence intervals and computing the confidence intervals for different testings of hypothesis. Dear students, I hope you understand the concepts behind all the decision making issues which were discussed in this lesson. We will continue in the next video. Thank you.